Please settle down. We will start the webinar with the Philippine National Anthem.
Tumayo po tayong lahat, ilagay ang kanang kamay sa ating dibdib at sabay-sabay nating awitin ang pambansang awit ng Pilipinas.
Bayang magiliw, perlas ng silanganan, alab ng puso, sa dibdib mo'y buhay. Lupang hinirang, tuyang ka ng magiting, sa manlulupi, di ka pasisiil, sa dagat at bundok, sa simoy at sa langit mong bughaw. May dilagang tula at awit sa paglayang minamahal, ang kisap ng watawat mo'y tagumpay na nagniningning, ang bituin at araw niya kailan pa may di magdidilim. Lupa ng araw ng luwalhati pagsinta, buhay langit sa piling mo. Aming ligaya na pag may mga api, ang mamatay ng dahil sa'yo.
Hello. Good morning, everyone.
Good morning, Mikey. Good morning, everyone.
Good morning, Patrick. Please unmute your mic.
Good
Yeah.
morning.
Good morning, everyone. I hope everyone is fully awake. We're starting
Yes.
early and on time.
Yeah.
Yeah. And in some participants around the globe, good afternoon and good evening, especially in the USA for our speaker.
Yeah.
So,
Morning, evening.
good evening. Yeah. Welcome to the DX Technology Beyond Horizon. What a great way to start our morning with fresh and new learnings to be given to us, of course, by our distinguished speaker.
Okay, this webinar is brought to you by the Radio Engineering Circle Incorporated in collaboration with the Board of Aeronautical Engineering of the Professional Regulations Commission.
We are your host for this morning. I am Mikey Zabat.
And I am Patrick Georgian Hulipas and
With us?
Orlan Vicente.
Yes. And now to officially start our DX episode 2, please welcome the chairman of the Radio Engineering Circle, Engineer Gerhard Tan.
Yeah, good morning, everyone. And it's a great morning ahead and evening there in US and across the region. Well, this morning, it will be another fantastic webinar for everyone because we'll be talking about aeronautics and avionics technologies. and it's something that for other engineers new, and even on my profession, I deal with telecommunication. So this one is something that is also new on me because you're dealing with aerodynamics and all those stuff, how aircraft will work, how shuttle will fly up the sky, and all those stuff. So I hope that everyone will enjoy and maximize your opportunity this morning to be able to network yourself to everyone and likewise ask questions. Take this opportunity to be clarified and be well versed with the different aeronautics and avionics technology. So I welcome everyone in this morning's webinar, the Space Episode 2 on the DX Technology Beyond Horizon. So I can see a lot of participants even in our region, in Region 2, from Tuguegarao, Isabela, and even in the Visayas and Mindanao region. Welcome. And I also want to reach out to the other Asia Pac country, the likes of Singapore. I think I've seen one, yeah, from Singapore. And yeah, of course, the Gulf region, Qatar, yeah, Saudi, and Oman, UAE. So welcome everyone and thank you for participating in this morning's webinar. Sit back and relax and enjoy listening to our speaker. Good morning, everyone.
Okay, thank you, Engineer Tan.
Again, to remind everyone, just in case you will post your photos on Facebook or Instagram, kindly use the hashtags #RecFreeWebinars, #DX, and #Technology Beyond Horizon. And if you have any questions, you may type it in the Q&A box below, and we will try it to answer most, if not all, at the open discussion with Mr. John Basie. Okay? So, Sir Arnan, Pat,
Yes.
Yes.
let's welcome
Good
first
morning.
Pat. It's his first time hosting.
Yes.
Uh, just for the knowledge of everyone, Patrick Colipas is the president of Radio Engineering Circle. So,
Yes.
yay!
Yeah, we're good to have you here,
Yeah,
Mr. President.
Thank
very
you, sir.
versatile.
Thank you,
Yeah,
Mikey. I'm also the controller right now for our social
Oh,
media
multitasking.
pages. And
multi-purpose.
yes.
Yeah.
Yeah.
So, what
Okay.
are we to discuss tonight? As what Sir Hard or Engineer Hard said, we will tackle something about aeronautics and avionic technologies. So I
Yeah.
believe that there are some participants from Board of Aeronautical Engineering. So
Uh,
I want to
from
welcome,
PRC. They are a member
PRC.
of POP-RB.
yes, so welcome everyone. So I think this will benefit everyone. So not just them, but also us. It's a new learning for everyone, I guess. So yeah.
Okay. Yes, so without further ado, let's introduce our esteemed guest this morning, Sir Ornan. Please do the honor of introducing our guest.
Yeah, thank you, Pat. This is really a great honor to introduce our distinguished speaker for this topic. He is a graduate of Bachelor of Science in Electrical Engineering and Masters of Science in Electrical Engineering at the University of Maryland in USA with honors.
Wow.
He has worked on many of the industry's largest and most challenging programs, particularly on defense, aerospace, and aircraft industries. While in NASA, he has involvement in the following projects in Houston, Texas, such as International Space Station, Titan 34D, Space Shuttle launches, Lunar Orbiter or the Artemis, Moon Base, Moon to Mars, and SpaceX. He designed and implemented data acquisition systems and data reduction systems for airborne and space platforms. He has developed encoded algorithms for these systems, as well as developed data products for evaluating flight data. He designed and implemented software to load, control, monitor, and troubleshoot ISS flight software, simulations, and network operations. He coded to extract data, inject values, and control processes. He helped to design and build the SDIL lab, which now performs all the flight software integration and checkout. He has directed and participated in flight test programs for many air and rocket vehicles. Also, while in Boeing, he led the systems integration and checkout of the Boeing 787 for first flight and delivery in Everett, Washington. He has planned and directed many aspects of flight test programs, which include B-787, F-22 fighter, B-1B IUS. Some of those tests includes high-speed taxi, RTO, load tests, high-lift tests, autogap tests, and performance tests. Additionally, he developed and directed tests to be executed on the flight control test bench and involved safety of flight of Boeing 787 development in Everett, Washington. Work on the avionics software development and test for the F-22 fighter in Seattle, Washington. Boeing Military Aircraft Division has the avionics contract for the F-22. He supported the integration and flight testing of the prototypes at Edwards Air Force Base in California. Later, he helped design and implement avionics test line in Seattle to support additional capabilities. Work on the integration and test of the B-1B bomber avionics systems. Much of this work was in support of the flight test programs at Edwards Air Force Base, California. He developed and coded ground test software for integration and checkout. Much of that software was directed at the integration and checkout of the Westinghouse radar. He developed software to activate the B-1B radar on the ground and exercise the modes of operation. He has extensive RF and microwave experience, having designed, tested, and developed many RF-related systems such as radar, DF, avionics, and antennas and other components. He is a pilot and can operate and fly many of the simulators for Boeing products. And last but not the least, he is the husband of my good friend during. So let's all welcome Mr. John W. Basie. Good morning, sir.
Good morning from Houston. That was quite an introduction. This morning, my name is John Basie. I'm talking to you from Houston, Texas. We're going to cover a lot of topics today, primarily avionics. Everybody has an interest in avionics, whether you know it or not. When you're sitting in an airplane flying across the ocean, your safety and your life depends on not only the pilot, but also his instruments, the computers on board, the software, all the subsystems, all working together. So avionics now is really integral part of our life. I'd like to start off, if I could, with a little clip. The apex of the integration of avionics and aeronautics is probably best illustrated in the B-1 bomber. This bomber has four-man crew, because there's so much hardware, there's so much going on in that cockpit that it takes 4 men to run the machine. So here's a little clip of the B-1 bomber. He's diving down toward the desert floor at Edwards. Can you see it all right?
Yes, sir. Please show me.
Okay, here's the B-1 bomber has a radar in the nose.
Sir,
You
please
can-
share. Hi, Sir John. Please share
Yeah.
your screen, sir.
Now, what am I supposed to share here?
Are you going to share some image?
I can't get my toolbar here. Is that better?
Yes. Yes, sir.
Okay. Let's roll this back a little bit. This is the B-1 bomber. It's got a forward-looking radar that maps the terrain in front of him. And the pilot's able to fly right down on the deck. He's maybe 20 or 30 meters off the floor. And that's so he can avoid radar detection. Very sophisticated airplane, has a tremendous amount of electronics and computing power. And we built this out at Edwards and flight tested it. Now it's deployed around the world. This is probably the best illustration of man-machine interfaces. It takes 4 people to basically run all the systems on the airplane. As you can see, they're down low. They fly down the canyons and then up over the mountains. And when they're in a mode, an auto mode, the computer's flying the airplane. Military airplanes are very similar to the commercials in that the flight controls are all here between the pilot and co-pilot. Navigation systems are directly in front of them, and then the engines are up here in this upper part. So there's a tremendous amount of information being supplied to the pilot and the co-pilot. And it takes quite a bit of training. They spend hundreds of hours in the simulator before they get in the airplane. Behind the pilot and co-pilot is the defensive and offensive operator. Go through this little door and you're up in the cockpit. The offensive officer sits here, the defensive officer sits here, and they have radars and ECM systems. And they run those systems to protect the airplane from enemy threats and to find targets and deploy weapon systems against those targets. The reason I'm showing this is sort of the apex of integration of avionics and aeronautics. Well, this is a better view of it. These are all the systems that the offensive operator runs. He's got a radar that looks for targets. This is a defensive guy. He's got a lookup of all the threats in the area and how to defeat that threat. Okay, let's talk about details of the function of the airplane. When we first started out, the term avionics refers to aviation and electronics, and they combine the word to avionics. So right now, it loosely means anything in the airplane that is run by electrical. The first airplanes, of course, all they had was communication, this one box. They could call and talk to each other. From that, they went to navigation, and then eventually they incorporated weather, and then they got more sophisticated. They have onboard control systems. So right now, this is sort of a scaled down block diagram of an airborne avionics system. So this is what it allows to do, to navigate, control the flight behavior, survey the weather, communicate, and then manage all the onboard systems. And this generates data for the flight controls. You'll have an angle of attack, you'll have airspeed, you'll have vertical speed, vertical altitude. So this is a scaled down model of what would be on a normal stripped down airplane. Now, today's airplanes, like a commercial airplane, will have additional systems. This is the in-flight entertainment system. These are all the subsystems that are on an airplane, like the 747 or the 777 or the 787. I'll go through a couple of the ones that are maybe of interest. This is a new addition here. This is what's called the electronic flight bag. You've probably seen the pilots at the airport. They'll carry a big square suitcase with them full of maps and so forth. Well, the new one is it's all electronic. The data is uploaded to the airplane before they get in the airplane, their mission, all the waypoints, the approach maps, everything they need is loaded up electronically. Once they get in the airplane and fire it up, these additional systems come online. It also has a system now. Most of the airplanes have a system for the airborne communications and control reporting. This reports back to the depot or to the next destination the status of the airplane. So if you're on an airplane flying from Manila to Seattle and there's a problem with somewhere on the airplane, say there's an overheating generator or something, this system detects it and sends a message to the base in Seattle saying you need to replace this particular component. So that component is waiting at the gate when the airplane lands. So the crew can go out and replace that particular problem, that LRU. LRU is a line replaceable unit, and the airplane's ready to go again. Additionally, all the airplanes now are required to have a cockpit voice recorder and a flight data recorder. This allows the operator to play back parts of the flight, or if there's an accident, they recover these boxes, take them to the lab, and try to figure out what went wrong with the airplane. This is a requirement now on almost all commercial airplanes. The intent of this diagram is to show that there's a lot of open ports for people to do mischievous things, hack, or interfere with the flights. The coding of all this software is supposed to be hardened so that it's very difficult for somebody to come in and issue erroneous commands. That whole area is a major effort right now, is to harden not only airplanes, but any system from being hacked. Almost all airplanes now are going to this, what we call the glass cockpit. Glass cockpit means we have, in the old days, we'd have a little round display like this. There's so much information, there's no room for all the gauges. So the sensors and all get integrated into a display. This one I'm pointing at is the attitude reference system. It tells the pilot where the horizon is, he's climbing, descending, turning, so forth. The next one over is the horizontal situation display. This is where the pilot will pick out his waypoint and fly to a particular point or airport. And then the central one here is what we call a multifunction display. It'll call up engine status, fuel status, the health of the airplane. So it puts up lots of data. And it's redundant. This is the co-pilot side. This is the pilot side. If you ever get on an airplane and look in the cockpit, you'll see that almost everything up there is just a glass cockpit now. The co-pilot and pilot, these little clipboards, they put their approach plates on this. This is how they're going to fly when they get to the airport. Whether they're going to make an instrument landing or EME landing or vortex landing. And their warning lights here, these are warning, caution, passenger caution. When something seriously goes wrong, these guys come on blinking, which basically tells a pilot and co-pilot they got to do something quickly or It'll be in the headlines tomorrow. If there are any questions as I go along, I'll elaborate. Okay, there are lots of standards when they go to designing an airplane, the avionics. These are all the organizations that have standards that have to be met. Some of them are obvious, FAA, European equivalent is the European Aviation Safety Agency. NASA has regulations. There are all kinds of standards for how to communicate on the airplane buses, the format of the data. So they try to make everything uniform so that so there's some conformity across different types of airplanes. In fact, most of the airlines, when they come to Boeing and they want to buy a new airplane, they want their glass cockpit or their instruments to look like the last airplane. So the pilot can transition from a 737 to a 777 with the minor changes. So the airlines actually specify what they want in the cockpit and how they want the cockpit laid out. So that helps them in their training and the transition. Okay, let's talk about a little more detail. Almost all the systems on the airplane now are automated because of the workload of the pilot and the co-pilot. That means basically that anything that the computer can do to help the pilot or co-pilot achieve a task, they let the computer do it. Navigation is already preloaded. The frequencies for the nav aids are preloaded. And lastly, the autopilot and the flight management system basically fly the airplane once it's up and en route. The autopilot will stabilize the airplane at a certain altitude, maintain the wings level. Flight management system will pick out the next waypoint and navigate the airplane to that waypoint. And basically almost all this can be done hands off by the pilot and co-pilot. Yeah. A lot of the flight planning is automated also. The navigation management as to the sequence for which the airplane will encounter the navigation aids is all sequenced. Engine controls are also maintained. The newer airplanes have what we call auto throttle, which basically coordinates engine thrust with the maneuver of the airplane. There's also a monitors the performance of the airplane, warns the pilot when he's outside certain margins, and they have some that help minimize fuel consumption. Likewise, this engine control management system is a new system they put on the airplanes that help the engines run more efficient, helps to control the engines for particular maneuvers. Almost all the airplanes now, like the 787, has 3 large main computers down in the equipment bay, which is below the cockpit. These 3, it's sort of interesting, I worked on this for a while. The 3 computers are all computing the same task at the same time. So they're all running the same program, and they go out and they check each other. One of those 3 is controlling the airplane. The other 2 are just monitoring. If the computer controlling the airplane has a problem, and the other 2 find out that they compute something differently, and that's significant, then they will disable that computer, and one of the two standbys will take over. We have the computers checking on computers. And then there's a lot of background processes that are maintaining not only the fuel flow, but balances of fuel in the airplane to keep the airplane stabilized. We have systems maintaining the power to the system, likewise with hydraulics. There's environmental systems, there's warning systems, and maintenance monitoring systems. So the maintenance monitoring is what basically alerts the ground crew in advance that an airplane coming in has a particular problem. This is done via a satellite link from the airplane to the ground station. Almost every avionics system has mission requirements, whether it's going to be a commercial airplane or military or a transport airplane. So these are the block diagrams that are basically captures those requirements and flows them down to the system. So when you get down to the software code and test and integration, you basically are trying to meet all the requirements that are set up here at the highest level. And if you go to work for any of the aerospace companies, this is probably where your first job is going to be figuring out what are the requirements and either developing code or test procedures to verify them. Before the airplane ever flies, the mission software and all the other software is basically captured in a simulation, and it's run many, many times, debugged and refined in a simulation before it actually flies on the airplane. This is where you can see the different segments of software. There's a pre-flight, taxi, takeoff, climb out, cruise, descend, approach and landing, rollout, post-flight. Each of those are a very unique configuration for the airplane. You don't realize it, but when you're in the airplane and it starts to taxi, the onboard computers are already detected that you're in a taxi mode. And it sets up certain criteria in the taxi mode. So the avionics is probably a major part of the airplane. In some airplanes, it's 20 to 30% of the cost of the airplane is in the electronics. There are lots of other requirements too. Once you build a system, there has to be able, of course, to stand the temperature variations, vibration, electromagnetic interference. So the environmental requirements have to be met on all the boxes that go in the airplane. Well, here are some of the considerations. Of course, reliability is a big factor. How reliable is that particular component? And how well can you maintain it? Everything should be line replaceable. So if there's a problem, they go in there and pull the box off the airplane, put another identical box in, and the system's ready to go. These are all considerations that the engineer has to take into account when he's designing something. And of course it's before anything can be used commercially, before you can put passengers on an airplane or even the military, it has to be certified. This is a big effort here. Certification means that it meets all the requirements and it's safe to carry passengers. And as in the case like with the 737 MAX, the FAA certified the airplane, and it turns out they shouldn't have. it had certain software flaws that basically resulted in the crash of 2 of the airplanes. Boeing went back and found the problems with the software and the sensors, and has since replaced the sensors, added additional sensor systems, sensors, and recoded the software. So right now they're trying to get it certified. But it was a big embarrassment to FAA and to Boeing. This is the first time Boeing's ever had a problem like this. It cost them billions of dollars, and it hurt their reputation. So this certification is a very important area. Then there are other things that you have to look at that are important. Weight and power is always important. Try to slim down as much of the systems as possible, make them as light as possible, and harden them against other threats. So almost any of these areas, you become an expert in one of these areas. You become an expert in packaging or in hardening or in the testing. And basically, when you have a design, you integrate it all together. You're going to have buses that carry the data to the different boxes. And those buses all have a certain protocol. So the way it works now is all the boxes are either have their discrete wires running between them, or they sit on a bus and they communicate on that bus. And these buses are basically the lifeblood of the system. It lets all the systems talk together. It collects the data up. It looks for errors in the system and in the data. I'd just like to talk about some of the boxes that are on an airplane, so you'll be familiar with the terminology. This HUD is a heads-up display. You've probably seen it in, I don't know, Top Gun or some of these movies. This allows a pilot to look out through the windshield, so he's not looking down in his lap at the screen, and it puts up on this transparent piece of glass the information he needs to fly the airplane while he's looking straight ahead. It'll have his attitude, speed, lots of parameters up there for him to look at without having to look down. And now they have this in the commercial airplanes too. So when a pilot's on approach, he's looking out the windshield hopefully at the runway, and the data displayed to him is his altitude, his approach speed, and things like that. So he doesn't have to take his eyes off the runway to fly the airplane. Multifunction display allows him to call up all types of functions in the airplane. Anything that's being formatted that's of importance. It could be warnings, it could be maintenance, it could be nav systems, it could be he's looking for a new airport. He can put in here the symbols and pull up the new airport. Stores is basically on a military airplane, it's any kind of hardware ordnance you have on board. And it talks to the rest of the system on its own bus. So you have a big display processor that runs these guys. It gets information from the INS. This is the inertial navigation system. The air data computer is the airspeed and temperature and rate of climb information for the airplane. Stores management tells him how many missiles he has left, or bombs, or whatever's the mission. The radar basically displays targets, threats. The radar altimeter is a device that radiates a beam down at the ground, and from the return, it determines the absolute altitude of the airplane above the terrain. Then there's a radar warning receiver that warns him when he's approaching the terrain. Basically, it'll send out a warning sound, and even now they have a voice saying pull up, or something like that. These are basic systems that are on the airplane. Okay, one of the airplanes I worked on for quite a while was the AWACS. And the reason I'm covering the AWACS is it has a lot of unique avionics in that airplane. You've probably seen it in movies or maybe even seen it flying. This airplane was designed by Boeing. It has a huge radome on the top. And in this radome, one side has a radar and the other side has a transponder. And basically, when this thing is flying, you can map everything in the air, everything in the ground, everything in the water, identify it, and basically provide that information to a crew of maybe 10 or 12 people. And from that information, they talk to the other airplanes in the area as to what is a threat, if the threat's coming in or going away, and identifies a threat. These airplanes now are used, Japan has them, Korea has them, Saudi Arabia, the Europeans, the Brits. There's several slightly different versions of it, but it's basically the same thing. You got a huge airborne radar. And the reason you need this radome is the radar is very high power. And you need to get it away from the crew. So as you can see, there are no windows because of the energy this thing is putting out. It has lots of antennas that picked up other types of communications. All these little, when you see an airplane, you see the little stud things sticking out, they're all antennas. And there's some antennas that are embedded in the skin of the airplane. So this is an example of the integration of avionics into an airplane that's very sophisticated. When you have a radar up in the air, you can see lots of things. This would be a typical radar display. And normally displays code the airplanes. If it's green, it's a friendly. If it's a red, it's a threat. And if it's a gray, it's an unknown. And this is a simplified display, but normally they'll have lots of information as to their speed, altitude, what kind of airplane they think it is. This whole field of airborne radars is very sophisticated, very interesting. You have a moving radar platform, so you have to be able to locate your orientation and your longitude and latitude pretty accurately in order to put up a meaningful display. One of the most promising areas now for aeronautics and avionics, of course, is this private shuttle airplane. You've probably seen these designs before. The fact that we can now come up with a fairly efficient battery means we can start thinking about electric airplanes. And the reason that's important is a small airplane like this, if it's conventional with an engine, is very loud. The electric ones are very quiet. That means that they can fly in metropolitan areas. There's no pollution. Maintenance is very low. These motors will run forever. So you don't have all the complex maintenance of a piston or turbine engine. And the fuel, there's virtually no fuel consumption. It's all electric. So this is a very promising area uh, for avionics. I think in the future, will be a tremendous um, growth in the area of basically their autonomous air taxis. There's all kinds of designs. You've probably seen some of these designs, but basically these are electric motors running propellers. They're redundant. If you lose one, the other two are programmed to take over the load. The real limitation right now is the weight and efficiency of the batteries. But NASA has one that's basically goes 100 miles. Well, this kind of design basically will take you from Makati to the airport. That's the kind of design they're thinking of. Of course, they're going to have all the avionics for airplane. You've got to have communications, radar. You got to have a flight controls. So it has all the capability of a regular airplane. I think this is probably a very interesting area. See if I got a good. Some of these are actually flying now. I think China has a fleet of them. Let's see if we can get past this. Yep, sorry about the advertisement. One other area I worked in was it's called an anechoic chamber. This is a large chamber with the RF absorbing material all around it. And in this chamber, we study the reflections off targets by certain radars. And the idea is you kill all the multipath, so you're really just seeing it, energy coming from the target. And from this chamber like this, we developed the stealth fighter and stealth technologies. Some of these rooms are massive. You can put a whole airplane inside of them and put your radar back here and you illuminate it and see what kind of cross section it has. So that's a whole new other area of aeronautics. We design antennas so that they don't reflect back energy if they get illuminated by a threat. It's just a whole another discipline. Edwards Air Force Base has a big chamber out there that we used as part of their ECM capability. ECM is electromagnetic, using electromagnetic warfare, EM, EW. Okay. This concludes my lecture on avionics and aeronautics. I think if there's any questions, I'd like to entertain them at this time. Hello.
Okay. Thank you, Mr. Basie. So we have a few questions here in the Q&A box below. So the first question is from Nile, Gel Ortega, what's the difference between 737 and 777? How can a passenger tell which one he's in?
The 737 is a smaller airplane. It's used primarily for regional type flying. It goes from, in the US, it goes like San Francisco to New York, it's about as far as it goes. The 777 is a transcontinental airplane. It's bigger. It's been the workhorse for Boeing for some time.
Mhm.
The 737 is an older design. Up until the 737 MAX, it was the safest airplane in the world.
Mhm.
Well designed, virtually no accidents, easy to fly. The 737 MAX has probably ruined its reputation forever, maybe.
Since it's old.
The 737 Max, right?
Yes.
Yeah.
But the difference was they took the 737 and they put a bigger engine on it.
Mhm.
Well, the engine is heavier, so they moved the engines forward on the wing, and
Mhm.
that changed the balance of the airplane. And the airplane flight controls, when the airplane goes into a stall, this is a critical part of the flight controls, is it has to be able to recover the airplane before it hits the ground.
Mhm.
And it also tries to prevent the airplane from going into a stall. So that software had some problems. So when the
Okay.
pilot took off, I'll just tell you briefly what happened. The pilot takes off from the airport. He's inexperienced. He pulls the nose up because he's climbing.
Mhm.
Okay. The software has only one sensor, and that sensor was in error. It was telling him the airplane's way up, the nose is way up. So the flight controls are starting to push the nose down, and it's sending him a warning that you're in a stall mode. And the pilot got confused and basically gave it full power
Mhm.
and pulled back on the yoke as hard as it could. But the trim and the tail was already set for nose down, and he couldn't overpower it. He should have trimmed it back. So he fought the controls all the way till it impacted the ground.
Mhm.
So that software and the sensors
Mhm.
were the problem.
Okay.
We had two accidents. Pilots that were trained on it would basically just disable that software, trim the airplane, and then fly on to the destination.
Mhm.
The two pilots that crashed it were inexperienced and were trained.
Mhm. Okay.
Okay. Um, Next question, sir, from anonymous attendee. What simulation software do you use to test the design?
To test every design.
Yes.
There's all types of software. If you
Mhm.
most of the software running on the airplane is what we call real-time software. It's running continually. VxWorks is one of the popular ones. That software comes with a package of diagnostic tools where you can load these diagnostic tools and it tells you how well your program's running, uh, if there are any queue overflows, if there's problems with it. So there's some embedded software debug tools that come with that software. But once we build a particular subsystem, we test it. And we test it by putting it on, we have a test bench.
Mhm.
Okay.
We have a test bench that lets it interface with other boxes that it's supposed to talk to.
Mm.
The test bench may have breakout boxes where you can look at signals. So the next step is you put it on the bench, you run it with the hardware. You have instrumentation to tell you if it's working properly, if it's doing everything it's supposed to do. And from that, you debug it and get it working. And you go to a bigger integration. When everybody has their boxes working, we put it into a simulation.
Mhm.
And at Boeing, they have a simulation for the 777, 787, 747. It's a regular cockpit. You sit in it, you think you're in the airplane.
Mhm.
And the simulation lets you start the engines up, go fly. You can maneuver the airplane. You can do
Mhm.
lots of things with it in the simulation you can't do in real life. You can
Mhm.
go up and shut down all the engines and restart them, all kinds of things. So it's a progression. You start with the basics code, look at the code, go to the debug, then go to the subsystem, then go to the larger subsystem, and then go to the integrated system. And lastly, you go to the airplane.
Just a follow-up question. You told us about the major ability or major abilities of avionics system, and one is reliability. Like you said, it's a major test. So how do you test reliability, and how many testing should you perform to assure reliability of an aircraft?
The reliability comes right at the beginning. First of all the
Mhm.
components have to be certified. There's a big effort to weed out counterfeit parts. As you know, when we buy a part, it's certified through some standard. Well, there's a lot of counterfeit parts that look just like the real part. So part of our effort is to have traceability and weed out all counterfeit
Mhm.
parts. Then in the design, whatever the design is, we go through peer review as to whether it's a good design, what are the problems, whether can it do the functions it's supposed to do, and if it fails, what is the nature of its failure?
Mhm.
Well, ideally, almost any system will have some sort of failure.
Yep.
What you want on an airplane is for it to fail gracefully and not take down other systems.
Mhm.
So part of that is looking at the reliability of that subsystem and what role it plays in the whole airplane. Of course, it all gets added together. Pretty soon you got a system. The overall system has a certain reliability.
Mhm.
The system, if you look at the Boeing airplane, there's probably, I don't know, maybe 5 million discrete parts in that airplane. And probably most of those are avionics parts. So when you're flying, there's always something that's out of tolerance or starting to fail or something. There's always something.
Mhm.
Most of those are minor. In fact, on one of my first jobs, when we started to fly the 787, was our onboard maintenance system had so many error messages coming we couldn't decipher. We had error messages from anything from the galley coffee pot not working to the hydraulic pressure low or whatever. So you have all this mixture of data coming, lots of data. So we made software that basically scrubs out the unimportant ones and lets us look at the important ones. But reliability is built into the product. You got to build it in
Mhm.
and test it and retest it. So,
But was there any case or instance that everything, all the testing, it passed all the testing, but when it comes to the actual testing, it failed?
yeah, we have we have all kinds of systems fail all the time.
Mhm.
We're the thing is, when something fails, it's not like your car. If we have a major failure on any airplane, it has to be documented. It has to be reviewed. FAA has to look at it. And if it's serious, the FAA will ground the airplane, just like they did with the 737 MAX.
Mhm.
The 737 MAX, technically nothing failed. It wasn't a hardware failure.
Mhm.
The
Yeah.
software did what it was supposed to do, and the pilot basically didn't anticipate it. Uh, so technically, when it failed, when 737 crashed, it was a perfectly good airplane. The
Mhm.
sensor was, we did have a sensor that was, I take it back, the sensor was bad, but everything else on the airplane was working fine. It's one of the outcomes of this was that we don't use a single sensor. Boeing put multiple sensors to gauge the pitch angle of the airplane. So if one sensor goes bad, the other two will vote it out and they'll use the other values. So when something fails on an airplane, if it's serious, the FAA is notified. There's an immediate team formed to see why it failed, what were the ramifications, how to fix it. Is the fix going to be flyable? If it's something serious, it may take them to redesign a part, redesign a subsystem. And the FAA will ground the airplane until they think. But most failures are low-level failures that are easily fixed. Basically, almost all the components, subsystems are what we call line replaceable units. The technician will go in, pull that unit out, put another unit in, and fire it up, and it's ready to go.
Mhm.
There are lots of failures. When you're riding on an airplane, you don't see them, but the pilot has lots of, minor stuff that's coming up in the airplane.
Mhm.
Yes, sir.
And there's a question here. What is your opinion on the 747 MAX accident?
37. I think that's
Ah,
37.
yes,
Yeah.
737, as what you have mentioned.
What's my what? Opinion?
Opinion.
About, yeah, opinion.
Okay, you're all engineers. This is a good lesson for engineers. I worked for Boeing for many years. Boeing is a for-profit corporation. They make
Mhm.
billions of dollars a year. They're a very big corporation. So you're sitting on the board of directors and you always say, well, how can I make more money? Okay. So what happened was the accountants slowly but surely took over the company. This accountant says, well, if we manufacture this particular component in Czechoslovakia, we can save $1.50. If we do this, we'll save $2. And it just goes on and on and on. So pretty soon we have accountants making decisions that engineers should have made.
Oh.
That they want to cut corners, less testing, get this airplane flying as soon as possible. These engineers don't know what they're talking about. I'll go find an engineer that tells me what I want to hear.
Yeah.
So basically, the Boeing management is responsible for that mess. And they fired the head of the 737 program. But, the damage is already done. But for years, the engineers have been complaining to management that they're shortcutting engineering and not listening to their engineers. And finally, it blew up in their face. And like I said, it cost billions and billions of dollars. It's ruined Boeing's reputation. It's ruined the reputation of the 737, which is a great airplane. So damage, in fact, there are memos from flight development software engineers warning them that this was not a good design. But they didn't want to stop the train. They wanted to keep pushing to get this thing on the market because it's a bigger, faster version of the 737. And ultimately, it had 2 crashes. So there's a point in your career as an engineer where you got to stand up and fight like hell to say, hey, this is not right, this is not safe.
Yeah.
Even though you have a lot of big people saying it is safe, we need to make the money, you're just worrying about nothing. So it's part of your job as an engineer is to make sure things are safe and you don't kill people.
But it was certified by FAA, right?
Yes, and that was another one of the outcomes. The FAA has been so complacent with Boeing. They're virtually on Boeing's
Confident.
payroll.
Yeah.
I hate to say this, but the FAA, they're just a staff, and they look to Boeing for guidance a lot of times, And if Boeing says, oh, this is okay, we tested it, then they usually take Boeing's word for it because Boeing has been doing this for almost 100 years. So in this case, they let a lot of things slide they should not have. So FAA looks very bad in this too. They should never certify the airplane.
So
Okay.
it's about savings and money. Money.
Everybody involved
Yeah.
looks bad.
Okay. So next question, Pat.
Next question, sir. I think it's from Ren Mesada. Is radio altimeter the same as radar altimeter?
Yeah, they're saying radar altimeter. Underneath the belly of the airplane, there's an antenna that sends out pulses that strike the ground and come back up to the airplane. The time delay between those pulses can calculate the height. And so that's an absolute reading of the airplane above the terrain. And the reason that's important, if you're flying over mountains and you're coming in, say, to an airplane that's in the mountains, you need to know exactly what the height is above the terrain. The helicopter that crashed in Los Angeles and killed the basketball player,
Kobe.
yeah, yeah.
Yeah.
He has a radar altimeter on board, and it was
Mhm.
telling him that the ground is coming up. He's coming up to a slope of a mountain too fast. And we looked at the data recorder, and he was getting a warning: you're getting too low. The terrain is rising in front of you. Instead of turning around or whatever, he tried to. I guess he thought he could just hop over that little ridge and land,
Mhm.
and he didn't make it. So the radar altimeter, when you're coming in for a landing, is very important in mountainous terrain, because the airport has an altitude. Say you're landing at Seattle. Seattle's about 300 feet above sea level. But if you're coming over the mountains, Snoqualmie Pass in that area, they're 7,000 feet up.
Mhm.
So if you have a glide path to the airport, you don't take into account whether there's a mountain range between you and the airport, you're going to run right into the mountains. The radar altimeter warns you that the terrain is getting closer and closer. You got to do something. So it's a very good safety.
Mhm. Yeah. Since we have uneven terrains and a lot of mountains, especially I think for the pilots, it's actually their challenge. So it's a good sensor for them to realize that they're coming near the mountains. So
Yeah.
next question.
One
Yep.
one more thing: the radar altimeter is coupled to what they call a terrain avoidance system.
Yeah.
That system calculates if you're going to hit the terrain or not, if you're getting close, and it sends out a warning. There's a beeping sound. And sometimes they have an audio sound saying pull up,
Mhm.
and then they have a stick shaker that shakes the airplane stick to tell the pilot, wake up, you're
Yeah.
flying into a mountain. So
Mhm.
there's layers of safety designed into the
Mhm.
airplane.
So basically, it's a calculation that made by the sensor, like
Yes,
how close you are.
yes, and how
Ah,
fast it's coming up.
mhm. Okay. So next question. Uh, how are the plane's personnel cargo equipment shielded from the EMI, both man-made and natural, when it is flying?
Uh, all the systems are tested for EMI. EMI is electromagnetic
Yeah.
interference, and all the systems are tested to see how they'll react when they're in a high EM environment. Yeah.
I think this is very essential for aircraft. So
Margo,
next, yes, yep.
yeah, just to explain a little further. All the connectors have shielding on them. All the boxes have certain shielding.
Mhm.
Uh, we look at all the possible ways E&M can get into a box, into a system, and we try to defeat it. But normally the cargo, if it's a commercial airplane, the cargo is not powered up. There should be nothing powered up down in the cargo bay. So it should not have any effect on the airplane.
Do you have any simulation for that? Or like testing chamber to avoid EMI when it comes to actual testing?
Yeah, yes, they have tests they run for EMI, look for interference.
Okay.
The big thing is interference largely comes in through the antennas.
Mhm.
If you got a radar running and you operate another system on board, like the sat telephone or something,
Mhm.
you want to make sure that interference is very low. You put a spectrum analyzer on it and look and see what the interference is. And there's a spec for that too.
Okay. So next question.
Okay, next question. What is the difference between fly-by-wire flight controls and conventional hydraulic flight controls? Which one is better?
Oh, I'm glad you brought that up. Okay. The new generation of airplanes are what called fly-by-wire. Fly-by-wire basically means that you're not using a central hydraulic pump system to change the actuators on the airplane. So fly-by-wire you basically have the computer goes out and talks to a little motor out on the wing, let's say, and that motor will move a spoiler. If it's a big surface, the motor will crank up a little hydraulic pump that moves it hydraulically. So the reason we go to fly-by-wire is in order to move that, in the old days, we'd have a hydraulic tube, a steel tube would run all the way out there to the actuator and then it run back, return. And that tube is full of hydraulic fluid. It requires a big pump to run it. So that's a lot of weight. You fly-by-wire, you just have two wires that run out there to the electric motor to do the work. And it's also more reliable. So fly-by-wire just means we're replacing hydraulic tubes and fluid pressure with electric motors. So in a real definition of avionics, the fly-by-wire is now part of the avionics system because it's electric.
So fly-by-wire is better.
Well, it's better for fuel efficiency and maintenance and lots of other things. Reliability, I don't know, some of the fighter pilots like the old system, but the new system, they're even putting it on fighter airplanes now.
So it depends on the use, actually. So next question. From Paulo La Laguna. Good evening, Mr. John. Thanks for coming back. Can the AWACS radar detect incoming stealth aircraft such as the F-117 Nighthawk?
The F-117, yeah, that's a stealth airplane she's talking about?
Yeah.
Yeah, that's a Lockheed stealth fighter. And it's pretty much obsolete. We've come up with new stealth fighters. The stealth fighter basically allows a pilot to fly in hostile territory and not get shot down. Basically, they can't see him when you fly at night. If you looked at the invasion of Iraq, the stealth fighters went in there at nighttime and took out all the targets, took out the radars, took out all the anti-aircraft. And they couldn't see them, they couldn't hit them. So it's very unnerving. They tried everything to try to find them and shoot them down, but they couldn't. So it's a very powerful technology.
But can I don't know how to pronounce it, AWACS or AWACS radar?
AWACS? Yeah.
Yep. AWACS radar detect incoming stealth aircraft.
It's classified, but I would say this. Yeah, it's classified. Depends on how, when you say stealth, it depends on how stealth it is. Nothing is absolute. There's always something being reflected. And AWACS has a huge, powerful radar. And I think if anything got close, within, say, 50 miles, 100 miles of it, it could pick it up. It can pick up things you wouldn't imagine because it's powerful and so forth. But I'm sure that those types of performance things are all classified.
So Paulo La Laguna, this is classified.
Yeah, you're okay.
Yeah.
I'll have to brief you, get your clearance if you want to talk about any more AWAC stuff.
Yeah. So next question. I will just ask why Boeing airplanes are more prone to crash than Airbus airplane?
I've worked on both of them.
Yeah.
Boeing quality is much better than Airbus. And Boeing's record is much better. Boeing is not, those two air crashes just ruined Boeing's reputation, but in general, Boeing is very safe. Boeing, there's probably 10,000 Boeing operations a day taking off and landing. And last time I looked at 2018, Boeing had several million flight hours, operation hours, and they only had, I think, 0 deaths. So they went a whole year with no one killed on a Boeing flight where they're flying 10,000 operations a day. You don't realize how massive the aviation industry is prior to the COVID-19. This, if you looked at a map, there is a map. You can go to Google or somewhere. There's a map of all the airplanes that are airborne at any one time, and you'd be shocked to see how many airplanes are flying. So Boeing has a very good reputation, other than what they just did, and that's why it was such a shame.
Okay.
Okay.
I think, Mikey, we can call our attendees to raise their hand. Then
Ah,
we will turn on their microphone.
so
So they can,
for participants, we are encouraging you to, if you want to ask Mr. Basie live, you can raise your hand below as well. Just click the raise your hand, not literally raising your hand. So we will be able to what? To put you in the panelist section and you can ask Mr. Basie live.
And I have an interpreter standing by.
Yeah. So don't worry.
okay.
So anyone who wants to ask Mr. Basie live. So while waiting for them, let's
Okay,
proceed
let's
with another
proceed.
Q&A. Yeah.
Yes. How are the planes of the presidents, like the Air Force One, different from the usual commercial planes when it comes to avionics?
Air Force One is a completely different airplane. It's first of all, it costs, I think, $400 million.
Wow.
And the reason for that is the avionics. The Air Force One can take control of our armed forces while it's airborne. It has all kinds of defensive systems, communication systems, satellite communication systems. So when it's airborne, the generals and the president can command all the armed forces from that airplane. And of course, it has to have all the encryption and all the other devices needed. So it has quite a bit of electronics on board. It is basically a flying command post. And by that I mean that command post can activate missile launches, talk directly to naval forces, talk to the ground forces. So it's got quite a bit of capability.
Again, reminding all our participants to put your questions in the Q&A box so that we will be able to see it rather than putting it in the webinar chat. So, next question. In your opinion, which airplane engine maker or vendor is the best or most reliable in the market today?
If you're talking about commercial airplanes,
Yep.
I think Boeing is the most reliable. It's got a long history. It's I've had mechanics work for me that have worked on Airbus and Bombardier and the Brazilian airplanes. And mechanics are out there all the time working on the hardware. They tell me Boeing is much more serviceable, dependable, and design is better. So I worked for Boeing for quite a few years, but I think the record is pretty clear. Boeing is superior. In fact, Airbus would not be in business if it wasn't for the government subsidizing them. That's the only reason they are in business is the government's subsidize the airplane. So if you need an airplane for an airline, you can go to Airbus and get it for nothing down because the government will basically finance it for you. So it's very hard for Boeing to compete with that. That's why they're still in business. If they had to compete like Boeing, they'd probably been out of business 20 years ago.
So we have one participant who is raising his hand. So can we put him in the there? There he is, Mr. Regino Aspiras. Do you have any question? You can unmute your mic.
Hello, yes. Hi, good evening, Sir John.
Good evening.
Good evening, sir. Sir, we just want to understand how important that we keep our cell phones in flight mode and how does it affect the flight of an airplane and what interference does it cause? Thank you.
Uh, Flight modes of the airplane you're talking about? Yeah, yeah, you're very soft. Could you please repeat?
Sorry. How important that we keep our cell phones in flight mode and how does it affect the flight of an airplane and what
No.
interference does it cause?
The basically my career has been studying or working with radiating devices. The cell phone has virtually no effect. Okay, but the problem is the cell phone is manufactured by manufacturers all over the world. So they could make a cell phone that has spurious responses in radio bands where the airplane is trying to do something or communicate. Because a cell phone is not regulated like an FAA device, that's why they don't want you to turn it on, because it could have spurious responses, spurious energy. But generally, it has no effect on the avionics of the airplane.
Kasi unlicensed. Thank you, Sir John.
Thank you, Mr. Regino.
Thank you.
Yep. So
Next
next question.
question. Mm, okay. Uh, Good morning, sir. What are your opinion on the recent navigational issue such as ILS spoofing attack where it placed the aircraft and flying public on high risk? Does this issue being resolved considered on the design of the aircraft?
Absolutely. That's one of the big issues is how people can maliciously interfere with the flight. And anytime you're relying on a RF link, which the ILS is, there's a transmitter down on the a threshold of the runway that's communicating with the airplane, that's giving its guidance to that threshold. So if you have somebody interfering on that frequency, you can pull the airplane off course and have him land short, land in the ground, particularly if it's a bad weather where he can't visually see the airport. He's trusting his instruments. An instrument approach can be he can come down to 50 feet without seeing the runway for a class 3 landing. So if you pulled him off that approach by just a small amount, when he breaks out 50 feet above the runway and he finds out he's 5,000 feet short of the runway, he doesn't have time to recover. So you can crash the airplane. So any interference with navigation is very serious. The systems are designed basically to harden against that, but one of the ways we try to do it is to eventually we're going to get into encoding the signals so that only that receiver gets that particular code. Right now, it's very vulnerable. So it's a very serious issue, and it's very vulnerable.
So there is a follow-up question here about the flight mode question that was raised by Mr. Regino a while ago. There are commercial aircrafts that are already have Wi-Fi on board. How does this also affect on the signal? Or is there an improvement on the avionics system on the aircraft to consider having this Wi-Fi on board?
Flight following mode is
Flight
which mode are you
mode phone.
Oh yeah.
Because the in our flights, we are required to turn off our phones, eh.
Mhm.
And
But
right
there are
now there are commercial aircrafts that have already Wi-Fi on board. So how does it affect the signal?
yeah, or if
Yeah,
there's any improvement on the avionics system.
the Wi-Fi is a new system. Uh, Basically, they have a local Wi-Fi and they have a transmitter on the top of the airplane that gives you a satellite connection.
Mhm.
But that interference is the flights has all been worked out. They've studied it. It really does not pose a threat in that
Mm.
sense. What we've done is we've hardened a lot of the communication in the airplane. Almost all the commands now are encrypted, and they have a handshake and they're encrypted so that when the flight computer tells the airplane to go do something like set the flaps or aileron down, the
Mhm.
computer will send a message out to that particular device and it's encrypted. It does a handshake and verifies that the device is the one he's talking to, and then he'll issue the command. So it's very hard for them to hack into that. You know, there's always some vulnerability somewhere, but that's not one of them right now.
Mhm.
Okay. Next question, sir. From anonymous attendee. Where do I start if I want to start a career in the avionics industry?
You know, if you want to be an engineer in avionics,
Yes, yes,
Mhm.
sir.
uh, well, the big companies are the ones that do all the avionics, but there are some smaller ones that are doing it. You know, like with the drones, small drones. That's a growing field. But if you want to really get going, you need to go with a big company like Lockheed, uh, North American, Rockwell, Boeing, uh, and there's some other ones. You know, SpaceX or a lot of ones. Right now, there's lots and lots of activity in avionics.
Mhm.
Almost all the uh, drones now have large avionics packages. But I would say if you really want to get started, you can look at even the automotive industry. The automotive industry is going to self-driving cars. Those sensors and all are very similar to the avionics. So you could get your feet wet doing a, automotive electronics and then transition into avionics.
Mhm.
Basically, if you internship or if you go to work for a large aerospace company, you'll be doing work in avionics.
Mhm. So another question for this is about the lifespan of commercial aircraft. So what is the maximum lifespan of a commercial aircraft? Does it need retrofitting or upgrading for a certain number of years? Like how to manage it?
Yeah. Uh, that's a good question. Boeing, if you ever go up to see Boeing, they have these huge structures that takes part of the airplane and stretches it. It'll take a
Mhm.
wing and it'll flex it up and down 100,000 times until they break it. So they study the airframe and parts of the airframe to determine how much wear and tear it can take. A typical commercial airplane will probably spend something like 80% of its time in the air. And when it exceeds a certain number of hours, the FAA requires an inspection of the structure where they have to go in and remove panels, look for corrosion, look for
Mhm.
fatigue, look for cracks. So almost every airplane develops cracks and fatigues as it flies. So the actual hours is pretty much determined by the model of the airplane.
Mhm.
But easily 50,000 hours, 100,000 hours is not unheard of.
Mhm.
And a lot of times when it gets up to that level, the airlines, like American Airlines, will take the airplane and sell it to operators in Africa South America, other parts of the world.
Mhm.
And those people will fly it and crash it, basically. So
Yeah.
the airplane's life expectancy is pretty much determined how much money you want to put in upgrading it and keeping it flying. But if an airplane starts developing cracks in the critical areas, and that's going to affect the lifetime severely.
Mhm.
Well, a lot of it depends on the design of the airplane. Right now, the 787 has a lot of composite material, which is not as prone to cracking as aluminum. So the airplanes will probably start flying longer, or they're flying longer ranges, longer hours, and a longer life because of the materials that are being used.
Okay.
Okay.
That's the best I can answer that.
Yep.
It's always best to fly in a new airplane, though.
Yes, sir.
And
Don't
it's
ever fly
safer.
in a Russian air. Don't ever fly in a Russian airplane.
Yeah. It's safer. So next question. This is about the territorial airspace. Quite controversial. What is your stand regarding China bullying territorial airspace in the Asian seas? Does that justify any international airspace rules over ASEAN countries? Or if you have any
Yeah.
idea about
I think the Chinese are going to push everybody as much as they can to get away with it. The problem is, I think after this COVID-19 disaster, people have woke up to see that China is not the wonderful uh, government that they portray on TV, that they're really borderline criminal, if you, in my opinion.
Yeah.
So I think the rest of the international community will stand up to them eventually,
yeah.
and say, okay, if you do this, then you can't fly in our country. You can't fly to Europe. You can't
Mhm.
fly to the US. There are things we can do. There is international uh, treaties for flying
Airspace
over
rules. Yeah.
countries. Right now, I think China, they've always let people fly over and around their country with no problem. But I think
Mhm.
they're pushing the limits on the sea access more than the air.
Okay. I think.
That's very
uh,
controversial.
yeah.
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 And let's move on to
Erase that
this
last
question.
segment.
Huh?
Erase that last
Yes.
response.
Yes. Yes, sir. Maybe let's move on to this question. Do you think forward swept wings like X-29 can make a comeback someday?
Yeah. What is SpaceX?
Forward swept wings like
Oh, forward swept wing.
X-29.
Oh,
Yeah.
yeah. The problem with the forward swept wing is that it's very unstable. Um, and most designers want stability. And that
Mm,
when you can improve performance, but you sacrifice stability. And I think the design is proving not to be very attractive. It's very unstable.
Mhm.
Okay, sir. How about the supersonic planes?
Yeah, supersonic is the future too, but the problem is the noise uh, and the fuel consumption. Everything is going green. Supersonic won't be very green. The future is, I hate to say it, the future is electric, quiet, efficient flight. Unfortunately, the wealthy want to fly fast, and they'll be the only ones that can fly supersonic. So I don't think it has much of a future.
Mhm.
Okay, sir.
Okay.
Mikey, I think it's also our last question from the Q&A.
Yeah. So we
Uh, go ahead.
so we will have one last question from the Q&A box, and we will allow our Board of Electronics Engineers, the Philippines, to ask Mr. Basie live. So for our last question, How do, from anonymous attendee, whoever you are, how do aircrafts manage air traffic during heavy storm? Have you experienced a time or know a case when control tower people lost communication with the pilot during this critical case?
Yes. The When we have bad weather and you're in a congested area,
Mhm.
they basically prioritize the airplanes. You don't realize it. Like if you're sitting on the runway in Los Angeles and you're flying to New York, New York has very bad weather and the airport has congestion. The the tower in New York will call the tower in LA and tell them not to release the airplane until they tell them, even though that airplane won't arrive for 4 or 5 hours. They delay the departure so as not to overwhelm the terminal in New York. So a lot of that is uh, has to do with the coordination between the different sectors and so forth. But if the tower goes down, the rule is that the pilots continue on whatever the last instruction was until they get a different communication reestablished.
Mhm.
So if a pilot's holding and he loses communication, he'll continue to hold. If he's on an approach and he loses communication, he will continue the approach and land.
Mhm.
So the basic rule is you continue until you get new communications.
Mhm.
And if they have too many airplanes that they can't accommodate, they'll send them to another airport. So one of the rules in flying is the airplane that you're in has to have enough fuel to get to your destination plus another 20 minutes.
Mhm.
So if for some reason the destination is closed, you have 20 minutes to get to the next destination or an alternate.
Mhm.
So the rules, they take that into account. They know how to handle it.
Yep. So thank you, Mr. Basie. So for
Okay.
our BECE, you may now have the floor to ask Mr. Basie some questions. Dr. Alnar and Engineer Del Moro, if you.
Yeah, good morning.
Good
Good
morning.
evening, John.
Good morning.
Nice to see you again. Okay, it's very interesting topic, and because of this, a lot of our ECE students becomes interested in the field of avionics and aerospace, right? And these fields are also one of the fields in electronics engineering profession as stipulated in our law, Republic Act 9292. These fields are also listed in our scope of practice, I should say. Now, because of this, a lot of students are quite interested with this. And so in our present curriculum, electronics engineering curriculum. In our present curriculum, we identified 8 field of specializations. Okay, and this avionics and aerospace was not yet mentioned, but we have options. But schools offering electronics engineering program have option to add a certain specialization. So my question now is this: what particular subject can you recommend, at least 3 subjects, for this field to be offered as one of the specialization in the field in the electronics engineering curriculum?
I think a good field is the electromagnetic field, where they learn how to design an antenna, how antennas work, how radars work, how transponders work. Uh, we My first job was building antennas on a test range. You understand how the antenna throws the energy out, the side lobes, how to design a good antenna. The antennas are everywhere now. You have antennas on drones, airplanes. We're going to have them on autonomous vehicles. So RF microwave field is a good field, I think, to get a feel for it. The other one I would say is, of course, is programming, real-time programming. That's something every engineer should probably learn how to do now. How to code, how to make programs, how to run them, how to debug them. That's the tools that engineers use now.
Yeah, can you specify what particular, because the curriculum has already subjects on programming and as well as more in electromagnetics. And as far as programming is concerned, since they already have that particular subject in the curriculum, can you specify what particular like language or, that's in use in avionics?
Yes, the most popular now is the VxWorks. This is by
Okay.
Wind River. It's a real-time software. It looks like C++, but it has additional capabilities to spawn programs, build controllers, schedulers. If you can program in C, you can pick it up pretty fast, but it's a very powerful language. That's the language that Boeing uses for the space station. They use it for, I think, SpaceX uses it. Any system that's running real time, providing control, access, information. There are other ones other than VxWorks, but that's the one I'm familiar with.
Yeah, so probably there are participants joining now who are connected in the academic institutions offering electronics engineering program. So you can take note of that particular subject that John mentioned a while ago, and probably we can get in touch with you for more of this particular endeavor, because I'm pretty sure with this kind of activity, there are a lot of ECE students who become more interested in the field of avionics and aerospace. And because of that possible demand, we are trying to devise our curriculum to add another specialization related to this field. And so in doing that, we need some of your recommendation as to what subjects this school is going to offer, so that this field of avionics and aerospace in electronics engineering program becomes possible.
Yes, I'm available. Just have Ornan has my email address. And, there are lots of projects I would think that you could do in the Philippines. One of them is to see what they're doing in the general aviation. Just get your hands, it's good to see the hardware. If you can go to some of their avionics shops where they do the repair and all, and see how the technicians repair things. But I think the big thing is in avionics is they require a certain discipline, and it's very specialized.
Yeah,
I've had a broad, very, very broad approach, but most engineers don't. Most of them, they do the programming. They may never even see the hardware when they finish the program, and they know that program goes off, gets embedded somewhere, and does something. But most of that stuff is very, very specialized. If you're in avionics, you may work with weapon systems. You may work with bus communications. You may work with cybernetics. The cyber security is a very big, that would be another one I would recommend. Cybersecurity is a very big field. It's something you can learn on your own, take courses. And when you go to apply for a job, if you have experience or knowledge in cybersecurity, it's a big, big plus. Yeah, they pay a lot of money. It's probably the highest paying programming now is cybersecurity.
Yeah. So thank you very much, John.
Okay.
And
My pleasure.
Yeah.
For Engineer Del Moro, if you have any questions, you may now ask Mr. John Basie.
Basically, I have no questions, but I'm pretty much interested in what has been discussed. Actually, I had been answering some of the questions on the chat box, specifically on EMI interference, and Since I have a little background on EMI, I was trying to answer of them. I hope my answers are correct. Most of the airplanes now no longer ask you to switch your cell phones off, because the new airplanes now, the electronics in the airplanes now are being designed for EMC compliance. So once they are EMC compliant, they put it in the airplanes, then basically that's it. So what they normally ask you to do is to switch, turn your cell phones to silent mode, so that you do not disturb your co-passengers, and you put your cell phones or your tablets on the packets during takeoff and landing for personal safety. So I think they no longer, the new planes no longer are that sensitive to EMI. But we still have old airplanes. If you ride the airplanes that has turbo propellers, these were designed years ago, and the electronics on those planes did not consider EMC compliance. So they still ask you to switch off your cell phones during takeoff and landing. So you have to understand that what is applicable on one plane is no longer applicable on the newer planes, because the newer planes have been designed well.
Yeah, you're right. The real concern is, you got a cell phone, but it's not certified to any FAA or FCC standard. If it's made in China, it may have a noisy transmitter. I mean, it's an uncontrolled device, really. You make a phone call and it works for you, but you don't realize what kind of spurious responses it's putting out, or garbage or noise and so forth. So that's why the FAA is concerned, because basically the cell phone is a non-certified radiating device. So they're concerned about it.
Okay. So as what Mr. or Engineer Del Moro said, there's no one design fits all. So yeah, so any final remarks from Mr. Basie to our audience, to our participants? Mr. Basie,
Yes,
if you have any final remarks to our participants.
yes, I would. Hey guys, the future in technology is very bright. I mean, there's going to be
Mm.
major changes in the near future, just like us communicating with Zoom. Uh, Technology is driving everything. It's driving the way we live, the way we travel, um, the ability to do things. It's magnifying our ability to be successful, to get information, to organize our life, to travel. So I think the future for your generation, the younger generation, uh, lies in harnessing the benefits of technology to enhance your life. There's going to be lots of vehicles now that are autonomous, which means you don't have to drive to work. It'll drive you to work, and you can basically be at work in your car. So there's going to be some major changes in the way we live. The computer is taking a quantum jump here shortly with artificial intelligence. So the future is pretty hard to predict, but you can be sure that technology is going to drive a lot of the changes. You already see this with satellites and the effect of being able to predict weather and communication and so forth. So all I can say is try to broaden your horizon so you're not just specialized in one area. It's always good to be a specialist, and large of the time that's how you get paid, and that's where you make the most money. But for your own well-being, you need to be versed in other things. And I think the future problems are going to be solved by technology. If you look at the traffic in Manila, if we could come up with better transport systems, better management of the traffic, better vehicles, lots of other things, you can enhance the life of everybody that lives in Manila. Reduce the pollution. So I think technology can really benefit us if we put it to the right use. So I think the future is bright. I don't think there's going to be apocalyptic robots roaming the earth and that sort of thing. I think whatever machines we design and build will be machines we command for our own benefit, for the benefit of humanity.
Mhm. And can you share as well, Mr. Basie, about your next topic, which is the artificial intelligence on the episode 3 of DX?
Yeah,
Like
yes.
a brief background.
This artificial intelligence will have the biggest impact on mankind probably since electricity. Artificial intelligence will basically change the way you think, change the way you act. It'll help you predict the future. It'll help us with medicine. It'll help us with diseases. It'll help find us a cure to the Corona-19, hopefully, if it's still around. So artificial intelligence will invade every area of our life, including your basic personal stuff as your finances, your mental health, lots of other areas that you don't even anticipate. So I'll try to put together a good lecture on artificial intelligence because it's, like I said, it's going to have the biggest impact on your life when it's mature.
So, yeah, so for our participants, we have part 3 of DX with Mr. John Basie, and the topic will cover the artificial intelligence. So stay tuned. And on behalf of Radio Engineering Circle Incorporated, we want to deeply thank you again, Mr. John Basie, and your
My
wife as
pleasure.
well. And your wife as well for standing by if we need interpreter.
Yeah, she did good.
And of course, to our BECE for always being present every webinar.
Yeah. Can I
And
see a little inputs?
oh, sure,
Yes, sir. Sure, sir.
Yeah. Okay.
sure, sir.
I just find it very interesting in the chat.
Mhm.
Where's that? This inputs coming from Mr. Engineer Lagman. According to him, there is a course in aviation school called Avitech called Avionics Technology, which is a course in electronics and communication, especially for aviation electronics use in flights and on ground. The course covers the operation and maintenance of the aircraft instrument and in an engineering point of view. So this is quite interesting. Now I encourage those schools who plans to have this avionics and aerospace as their specialization in their curriculum. So probably try to consider this particular program. Try to visit this particular program and then try to get some points in here. This is a new, I should say, because this aviation and aerospace specialization was not stipulated in our curriculum, but schools has the option to add more specialization. So if schools are interested with this, and then try, maybe you can try coordinating with this particular school offering this particular program. So that's all. Thank you for the time.
Okay.
Thank you, Dr. Alnar.
May I, Mikey, just a very quick one.
Yes, sir.
Mr. Baisi and his lovely wife always travels to Philippines. Now, if there are interested institutions who wanted to have a meeting or a group meeting, or we can, if they want to arrange a sort of a forum. Yeah, if you can spare some time with this group to further our engineering field in avionics here in Philippines, we are very much appreciated. So I'll try to ask my good friend Marivic to put shotgun in you and say you can just say yes.
Yeah.
Okay, so we're looking forward to that, sir. If you could just
Yeah,
spare some
we
time.
find time. We were there last January, December to January, right?
Yeah, yeah.
Or one
Okay, so
anyhow. Next time.
let me know, sister, when your next trip to Philippines. Thank you so much.
When there's no COVID, we will be there. Right away.
Wow. Thank you for
Yeah.
your intentionality. Um, again, on behalf of the Radio Engineering Circle Incorporated, we want to again thank you, Mr. John Basie and Mrs. Basie, for acknowledging our request, our invitation to speak to us about the avionics technologies. Again, thank you. And we
Picture,
will
picture.
see you
You're
on
welcome.
part 3 again. So for
Okay.
everyone, all part of the panelists, um, can you please turn on your cameras and we will have our picture taking?
Join ka, sister. Join ka.
Yes,
Okay.
there.
Yan.
Who will take the picture? Oh, I'll take it. 1, 2, 3. Another one. Wait, na-pressure ako bigla. Wait. Another one. 1, 2, 3. Picture. Yep. Thank you,
Thank
Okay.
you.
everyone.
Thank you, everyone.
And
Thank
Thank you, everyone.
you.
Bye,
we will
Ornan. Bye,
Bye.
everybody.
Bye.
Houston out.
we will see them once again on the part 3 of DX. So all our participants stay tuned. And for our closing remarks, and for our participants, please don't leave yet. We will announce other announcements at the end of the closing remarks.
Hey,
So for our closing remarks, may we invite Engineer Ornan Vicente, the Vice Chairman of REC Inc.
Okay, thank you, Mikey. At first, I'd like to thank Mr. John W. Basie for again for this episode's discussion, and thank you in advance again for your artificial intelligence topic for our episode 3. Of course, thank you to Mrs. Basie as well, my good friend. And to all the officers of REC and to our distinguished guests in this webinar. And of course, to our participants, thank you very much. Please don't forget to register again. July 11, right, Patrick? July
yeah,
11.
yes, sir. July
So
11.
we'll have again our expert speaker, Mr. Basie, for the July 11 artificial intelligence topic. So watch out for the other webinar today. We have the BAC hour in a few minutes, 30 minutes from now, and this afternoon, another one, and this evening. Okay.
Mhm.
So again, thank you for supporting Radio Engineering Circle. If you want to join REC, please log on and register to the form. I mean, fill up the form, and we'll evaluate and inform you of the schedule of interview.
Mhm.
Okay, so thank you very much. Thank you to this technology, of course, so we can connect with each other and learn wherever we are. Thank you so much, and have a nice day ahead. Good night, Sir John.
All right. Good night from Houston.
Have a good night's sleep. Thank you for entertaining us.
Thank you so much.
And for our announcements, please flash. Everyone, let's acknowledge first our President, Patrick Georgian Hulipas, for being the
Yeah,
moderator at the same time the host of this
sorry.
webinar.
Hello.
He's the head of the control room and at the same time the
Uh,
moderator. He has no
thank,
choice.
thank, thank you, Mikey. And yeah, maybe we can announce
Yep.
today at 10:30 a.m. I think we have 30 minutes more left. Join us on our episode, the episode 2 of the BECR, with of course, the three members of the Board of Electronics Engineering, Dr. Alnar Detalia,
Mhm.
Engineer Enrico Del Moro and Engineer Herminio Orbe. So just register to webinar.rec.org.ph/ZZoneEP2. And tonight we have the part 3 of our Genesis of Emergency Communications in the Philippines, the Bayanihan edition. So our topic for tonight is about the RET-PH, the catalyst for the whole of nation approach in emergency communications, telecommunications. With our resource speaker, Colonel Edwin C. Sadang, PECE MNSA PA, the founder of RET-PH. Register now at webinar.rec.org.ph/resonate at home. Okay?
Shopee. Where's the
Sorry.
next?
Okay,
Next.
so for the let's if you want to join our circle,
Mm.
if you want to be a moderator or re- or host, so join our
Yeah.
circle. Log on to rec.org.ph/join. We're a proud member of Philippine Amateur Radio
Yeah.
Association and Federation of Rapid Emergency Telecommunications Team of the Philippines.
Mm. How about for the feedback form?
And the feedback form.
Yes.
So you need to accomplish the feedback form. Log on to bit.ly/dx space EP2FB.
Yeah.
Okay, we will try to distribute the certificates on
July
starting
12th.
July 12. Okay, so please bear with us because maybe you can join the rec so you can see
Can help out.
and help our organization to distribute the e-certificates. Yeah.
Yeah. And are
Later,
do they
yes,
need to
yes.
complete the three episodes of the
No, no.
space?
For the space, actually, we're preparing for the episode one
The certificate.
attend e-certificates
Okay.
for attend if you attended that the episode one you will get your e-certificates
Yep. So it
also
doesn't.
here. Yeah, it's a
Yeah.
separate e-certificate, so
Mhm.
don't worry.
Okay. So
So
yeah, we
yeah,
will
that
see you in 10:30 a.m. webinar. I hope everyone will be joining us there. And everyone, you may now have your breakfast. Thank you for
thank you.
waking up and bearing with us, staying us until the end of this webinar. Everyone, thank you and good morning.
Good morning.